everyone, I'm Yuki. Sorry I cannot show up in class, so I record this video previously. So my part is about the linear regression model, and in our part, we firstly we want to figure out which variables affect the price and how do they affect the price. So firstly, we did several correlation plots. We break up the dataset into smaller chunks so that we can analyze correlations visually, and we leave our response variable in all of the matrices to compare correlations. And you can see in our correlation plots, several variables have quite stronger and deep color chunks, which means those variables have a more strong relationship with the price, like the room type, accommodates, and bedrooms and beds. But we did dump some of the price and fee and deposit because those are affected by the price but not affect the price. So later we split our dataset into train and test with 80% to 20%, and then we run our first linear regression model with all variables included, like you can see in the read in the code, and also you can see the result, the coefficients list, but the result is not that good. It's with a low R-square, about 34%. But it does show up that there are some variables has significant correlation with price, and we decide to pick up them. And there's one thing that is weird and we cannot figure out why, is that for the variable zip code, for each zip code it gives a particular line with its estimate and standard error and t-value and p-value. So it just lists all the zip code one by one for each unique zip code. So later on we're gonna think about the zip code thing, and later we run our second linear regression model, which we select those significant variables, but we firstly exclude the zip code. And after we run this model, we can see it turn out to be a higher R-square with about 65% R-squared. But after we apply this model to the test data set, the R-square dropped by 22%. So we have to consider that this model may be overfitting or something. So later, for our third model, we include the zip code. Then it gives us a better result with higher R-square, about 71 or 72% R-squared. But when we want to apply this predict model to the test data set, but it always incurred an error, saying that some of the zip code is not found in the test data set. It's reasonable because some of the zip code may exist in the train data set but not exist in the test data set. So for currently, we have to say that the second model is our best for now, but there are two problems we have to figure out later. One is about the zip code, and the second one is about the overfitting thing. Yeah, so that's currently what I did for my part, and that would be all. Thank you.